We're both graduating from the Electrical and Computer Engineering Department at George Mason University this coming May. We're here, we're just going to test out our device that we use that uses sound.
Imagine a world without cell phones. Now, I know that might be hard to do because some of you are on your cell phones right now. But what did we need? We needed something. We needed to communicate. We needed to exchange ideas. We need to tell stories. And that brings upon necessity is the mother of invention. In our case, we need to graduate. So it's pretty, we needed to get it done. That being said, interest should be your best teacher. We didn't follow the other projects because we didn't find them interesting. And the reason our project was so successful is because we had a lot of motivation behind it. And here, my project partner will show you our project in demonstration here. Thank you. I hope you enjoyed that. Now, the concept of putting out fire with sound is nothing new. Back in 1865, John Tyndall experimented with his voice and projecting it at fire and noticed that certain tones would put out fire more than others. And recently in DARPA did their experimentation back in 2008. And they published their work in 2012.
So, as Viet was saying, DARPA did this research on the effects of fire and sound. As you can see, they have giant turbines that actually show that the sound was able to go out in about 10 seconds. It was bi-directional. The device that you just saw in the presentation above, it was unidirectional. It was very small, and it's pretty much an instantaneous output of the flame. Now, you can consider us more of innovators of the technology, since it did exist. But what came to happen is that DARPA had this device, and for whatever reason, they concluded that the device is not feasible for the United States military as an effective method of extinguishing fire. And being a government agency, they didn't really explain why. So if it's shown to actually work, why is this not a valuable option for the government or in industry and practical use?
And I forgot to mention, if you look closely, that's somebody's legs in the background. So it's quite, the fixture that they made is quite large. And if you noticed our video, it's very portable, very usable by anybody.
Right. Now, when we were doing our initial research, we came across the physical experiment of the Rubens tube. Now, what the Rubens tube is, it's basically a PVC pipe. On the left-hand side, it's filled with propane. On the right-hand side, just an audio speaker. Now, it has holes drilled into the top, and it's ignited, and basically the flame stands straight up. Now when you play music or any type of frequency tone, you see the flame patterns changing, showing that there's an effect on fire from the frequency of sound. Now with that in mind, we took it upon ourselves to figure out, since it has this effect, what can we do to actually extinguish fire? People showed it as a method of dancing around fires, but how can we make this a useful product? And that's kind of what we did here. To actually explain this phenomenon, you can look at the fire triangle. The fire triangle explains that fire needs three things to exist. You need heat, oxygen, and fuel. Now, if you remove one of these three options from the triangle, fire is completely suppressed. Now, we actually attack two of them. Sound moves as a pressure wave, meaning that it oscillates between high pressure and low pressure. So oxygen naturally wants to travel to these areas of low pressure in order to exist. Now, when you go into low pressure, at the fuel source, you're able to disperse the heat over a larger surface area. Now, this in turn decreases the pressure, and by the ideal gas law, also decreases the temperature. So you're removing heat and also agitating the oxygen molecules, separating from the fuel. So you're removing heat and removing oxygen. And these two in combination is what's suppressing the fire.
We want to let you know that this journey was not easy. Originally, we had a group of 5 people, and 3 of those people were very excited at first about the idea. And then as they did their quick Google searches, they found out that there was not much success behind a lot of past efforts. And we went from professor to professor try to find someone to sign off our project because it was something that we came up with ourselves.
Right. Actually, the professor of the class, when we first approached them about this project, they give you a list of about 15 topics to choose from. And that's basically what you need to graduate from an electrical engineering department at George Mason University. And with that, we saw all the projects, and we weren't interested in any of them. So, we didn't want to you spend basically 9 months working on a project, so we didn't want to spend on something that we didn't enjoy. Plus with another course load, that's just a phase, and, college is tough enough. Let's do something that we want to do, So anyway, we decided, Viet actually came across an article that said, firefighters in the future will one day use sound to put out fire. And we saw that interesting. We did a little more research. We saw that the tests that had been done in the past, but no one ever went forth to do a practical issue. So the main thing that he told me that motivated us to go about it is that this technology is going to exist one day. Why not be us to be the ones to create it? So that's kind of where we went forth with this project. And like a little backstory, we basically took an Edison approach to this project. And what I mean by that is when Edison did a lot of tests, he found thousands of ways why something didn't work. And when you find out something that doesn't work, eventually when something does work, you learn so much from it that the explanation is already there. Now, generally in science, you want to do your research, you want to conduct a hypothesis will have you, and a concept that basically explains how the device works. And then you ultimately do an experiment, hoping that it works. We did the complete opposite. We did our prototyping and testing first. We did a whole lot of methods that didn't work, and every time something didn't work, we learned something new. We learned something why it didn't work. And when we finally got to that range that was able to suppress a fire, the explanation was there. The theoretical concept, everything behind it was there. We knew why it worked from all the tests that we did. And a little backstory, I don't know if you guys have seen our video on YouTube or Facebook. Yeah, okay.
The sound frequencies to extinguish flames.
I see this device being applied to a lot of things. First off, I think in the kitchen, it could be on top of a stovetop. But eventually, I'd like to see this applied to maybe swarm robotics, where it'd be attached to a drone, and that would be applied to forest fires or even building fires, where you wouldn't want to sacrifice human life.
Professor Brian Mark really stepped in to help us.
Just gave us a lot of support.
I think as a whole, engineering is really just finding solutions finding simple solutions to complicated problems. Engineering.
I'm about to say, if you haven't, it will probably be the first search on there. But, this is actually a screenshot from the video. And basically what it does is how we got to this video, we originally made this device. We went to the fire department. We tried to do the right thing. We went to the fire department and we told them, we have this device. It puts out fires with sound. It's a new technology we have. We just want to demonstrate it here and show you that it works. And because we need a video for the class. You need to show your professors and students, your peers, that the device works. Now, when we went to the fire department, they basically told us, I don't know what you guys are talking about. This doesn't sound possible, and it sounds very funny to me, so we need you to leave and don't come back talking about this. So we said, okay. As we were told, we left. We went back to the school. We talked to a professor, and we asked her, she owns a lab at the university. We asked her, we have this device. We explained to her how it works, and we kind of showed everything to her. She said, okay, you can use my lab. Just make sure you have safety equipment in case anything goes wrong. We said, fine, we can do that. So we did our videos. We took the video and we presented it at the class at the final, the final presentation for the project. And we did the tests in the labs. It worked as expected. And then finally we showed it to everyone. We posted that video. This is one you haven't seen. We posted that one on Facebook and YouTube. And about a week later, we got an email from the fire marshals at our school. And I remember it like it was yesterday. We looked at it, and I can almost quote you what it said. Us being in the fire protection industry, we're very excited to see a technology like this being used for a practical matter. However, what you all did is highly illegal, and it violates hundreds of fire codes in the state of Virginia. So we need you to take the video down, or we're going to take legal action. So as you can see, we took the video down. But luckily, since we did have that out there, a lot of people did already see it. The school decided they wanted to do a video for us. So they provided us with a location outside. We did some testing. This is actually the video that you've seen online. We did some testing outside. We showed it work. And next thing you know, we got a call from the Washington Post. There was a guy, the school did their own article on it. They were impressed by students doing something like this. It was very interesting. Then we got a call from the Washington Post. And basically, they asked if they could do an article on us. We said, sure. They did, they took bits from the clip, and once they posted it, it was tasked from CNN, from CNET, New York Times, a lot of magazines. It kind of just blew up. We kind of really understood how something goes trending, and that was really an experience in how everything worked.
So after all that success, we decided to patent it and create our own company by the name of Force SV. Our mission now is to revolutionize the fire protection industry, and here we're featured in Ripley's Believe It or Not. But you can believe it because we're here.
It is. So, thank you. Thank you. And so, last thing I want to say in closing, I want you all to, especially people that are entrepreneur, young or old, if you have a drive, I want you to think about problems in your community, in your local family, in your personal activities, things that you call your friend about that you're complaining about every day. Think about things you could take action. Think about things that have traditional methods of solving problems and how you can make them more effective, how you can make something more useful, how it can be, not necessarily always being marketable, but how can you change the way we interact every day? And when you take that action, that's how the world changes.
And if you focus on three main things, it's whether you can save somebody money, time, or health. And if you can improve any aspect of that, you have the power to innovate. So we want to leave you with that.
All right, thank you guys for having us here.
That's what appreciate it.